26. Was this page 26? Okay, we're looking at the relationships between isosceles and equilateral triangles. We explored yesterday with the Desmos activity. Instead of me just straight up telling you the relationship, you were supposed to explore through that Desmos activity and try to draw conclusions about the relationship. Looking at the top, we have three basic vocab words of the three types of triangles. You have isosceles, equilateral, or scaling. An isosceles triangle has what? Two congruent sides. An equilateral, all three sides are congruent. The name itself is literally telling you the lateral sides are equal. Equilateral means all sides equal. Okay, and then scaling sounds weird. No equal sides at all. It's a triangle where no sides are congruent. Now, sketching an isosceles triangle where two sides are congruent, I tend to turn it upright so it looks like the roof of a house or like a tent, and then I mark the two sides that are congruent. For equilateral, you kind of have to stretch it out a little bit more, and all three sides are equal. And then, of course, scaling is there's no sides equal. We're going to look at first isosceles. There's some vocab words associated with an isosceles triangle. Here's an isosceles triangle right here. Anytime you have an isosceles triangle, I want you to turn your paper so that the triangle is like a rooftop. I want that to resonate like on repeat in the back of your head. Turn the paper so it looks like a rooftop. And what I mean by that is, like number 2. Is number 2 in position of a rooftop? No. So I would turn my paper that way so it would be upright, right? And then it's easier to identify what I'm about to tell you. All right, so we're going to turn it like a rooftop. So this is already turned like a rooftop. And I can clearly see the left side is equal to the right side. There's a vocab word associated with the bottom of the triangle. Makes sense. It's called the base. If you turn it like a rooftop, you can see the base. And then these congruent sides are called legs. The legs of the triangle. Now the angles have vocab names. When you have it turned like a rooftop and you can see the base, the angles that are down here, touching the base on the bottom, are called the base angles. Really creative there, isn't it? So in this example, angle A and angle B are base angles. It's really important that you know that vocab word and you can find the base angles. When we start practicing, I'm always going to say, turn it like a rooftop. Where's your base angles? That's what I'm going to say every time, okay? Because if you turn it like a rooftop, you find your base angles, the relationship is they're always congruent. And that's because it's an isosceles triangle. Here's what you need to remember. however many congruent sides is the same number of congruent, fill in the blank, louder, angles. I'm going to say it again. In a triangle, however many congruent sides matches the number of congruent angles. So if you have a triangle with no congruent sides, there are no congruent angles. If you have an isosceles triangle, then you have how many congruent angles? 2. Where are they? They're always the bottom base angles if you turn it like a rooftop every time. I love when things are consistent every time. I love when I can say to you, hey, it's going to be like this every time. Because then I feel like there's some comfort in knowing, like, okay, if I can just remember that, it's that way every time. There's one more vocab word. It has to do with this angle that is right here. That is called a vertex angle. And what it means is the angle in the top of the roof. Okay? It's called the vertex angle. All right, now there's a couple of theorems that we need to talk about. First of all, you see this word theorem here and here. I don't want you to get caught up in the word theorem. Theorem means it's a statement that we could easily prove if we wanted to. That's all theorem means. Don't get caught up in the word theorem. Now, let's look at this one. If two sides of a triangle are congruent, then angles opposite of those sides are congruent. They're telling you, if you know two legs are equal, then you know base angles are equal. Then it says converse. This is important to start wrapping your mind around. What do you think converse means? Not the shoes. Let me give you an easier example to understand. If you come in the room after the bell, then you are tardy. That's called a conditional statement. I said, if you come in after the bell, that's the if, then you are tardy. That's the consequence, right? All right, now listen to what I'm going to say. Here's the converse. If you're tardy, then you came in after the bell. What did I do? I switched it. Converse means you're switching it. It means you're switching the if this happens, then this can be said. You're switching it, and it still holds true. So we said if two sides are equal, then two angles are equal. This is saying, well, if two angles are equal, then there must be two sides equal. So that's called the converse, which means if I throw a triangle at you, here's what it means in a nutshell. If I throw a triangle at you and I say, hey, that is equal to that, then the arrow means then you should be able to say, okay, well, if that is equal to that, then this is equal to this, right? Or, here's the converse. If I say, hey, here's a triangle and these two angles are equal, then you should be able to say, okay, well, if those angles are equal, that's the base, then those sides are equal. Notice the end result's the same. It's a matter of what did I give you to start with. So I need you, the takeaway here, what do I need to actually know, Miss Holcombe? I need you to know that if there are two congruent angles, there's two congruent sides. If there's two congruent sides, there's two congruent angles. Where do you find any of them? You turn it like a rooftop. And then the left and the right are equal, and the base angles are equal. Okay? That's the takeaway. All right, now that's equilateral. That's isosceles. Now let's talk about equilateral. I love equilateral triangles because despite the fact that you could have a small one, a medium, or a big one, their angles never change. The angles never change in an equilateral triangle, ever. All right, so let's look at it. We have what's called corollaries. Corollaries is like a step down from a theorem. It means here's a small little statement that's so like simple and there's not much thought to it that it's called a corollary because there's no need to prove it. It's just something that is. If a triangle is equilateral, then it is equiangular. Sounds like a really weird word, but it is a word. And what does it sound like it means? If it's equilateral, it's equiangular. What does that sound like? All the angles are equal. If a triangle is equiangular, then it's equilateral. You notice how these two just switched? Now, the next part is where some math comes in. And some of you got here yesterday. I don't want to throw the number at you because I want to see if you can remember it or see if you can get there. If I tell you that you have an equilateral triangle, let's try to draw one right here. If I say, hey, here's an equilateral triangle, do you have enough information to tell me how many degrees are in each angle? Yes. And you might think, well, how? There's not a single number up there. Your clue is the fact that all three sides are equal. If all three sides are equal, then all the angles are equal. Well, what do we know the angles have to add up to? They have to add up to 180. So the total, regardless of what type of triangle it is 180. So how many degrees is each angle of an equilateral triangle? 60. And how did you get it? You took 60 and added up 3 times? Very good. What's another way to get there? That's another way to get there. I want you to draw this picture on your paper as best as you can. And then we're going to fill in this line that says each angle of an equilateral triangle measures 60 degrees. And we're going to write because 180 divided by 3 is 60. We're going to show how we got it. And at this point now, we're done with like learning the content, taking the notes on it. Now we're at the practice part. So it's like running the drills, before the big game. These practice problems start very simple. They get gradually more complicated, and then they get multi-step. Okay? I think you're capable of all of them. I know some of them might trip you up a minute, but I think you can work through it. I need you to get comfortable with possibly struggling through some of these problems, but getting through it, okay? You are at high school math level. Geometry is challenging. I need you to be comfortable with not knowing sometimes how to do it, but trying to work through it, okay? It's called patient problem solving, or productive struggle. And that's what I really want y'all to start learning how to have and manage, because it's a very good skill for in the real world. All right, so let's start. Let's dive right in. You've already started a lot of these. Number 1, we've got a triangle. We have clearly markings to show it's isosceles. Is it turned like a rooftop? Yes. Find your base angles and mark them, because then you're going to clearly see that x is 48. Okay, number 2, turn like a rooftop. Mark your base angles. See, if you don't turn it like a rooftop, red means wrong here. You might mark these as your base angles. Is that true? No. So you have to be careful. It might help to draw the congruent marks darker so you can actually see where the roof is, I guess. Then you turn it, and you should mark these congruent. So X is 75. Number 3 is slightly different. Why? There you go. The X is the vertex angle this time, not one of the congruent base angles. So it is a little different. There's a little math involved. You still turn it like a rooftop, find your base angles, and mark them. If you don't mark them, it makes it harder to know how to solve the problem. Mark your base angles congruent, okay? Then you can go and label, okay, well, if that's 72, this is 72, what is my total I'm working with? Always 180. So I can do the subtraction method. I can take the 180, go to my calculator, and subtract off what I already know. I know 72, 72, and that would leave me with what? 36? Thursday. I was trying to remember. Teen Maze is coming up. I hope y'all turned in your forms. They still take them, I think. Yeah, I think they're going to feed you if I remember correctly. All right, number 4. Looking at number 4. Is it different than the last couple of examples? Yes, it's a little different. Same concepts, it's just a little different. Because this time, if you mark your sides congruent, turn it like a rooftop, you'll see that you have here and here. Now there's a couple ways to go about this. If you struggle with the subtraction method, then I would encourage you to label that this is also X, and then what does the entire triangle add up to? 180. So you could write a long equation, X plus 74 equals 180. You could do that. That will work. I would like you to watch this method and see if maybe you like this better and try to adopt it. It's called the subtraction method. It's where you know the total is 180 every time, and you take off what you already know. So 180 minus 74, 106. So now I know I'm working with 106 degrees down here on the bottom. I also know, because I marked it, that they have to be the same, which is what my clue is. Okay, so the 106 divided by 2 would give me 53 degrees. All right, 5 and 6, what'd you get? 70 and 46. Now, 7 through 9 are challenging, like the next level, because now they're polynomial expressions instead of just plain old X. But let me show you another technique for having smaller equations, smaller numbers, All you have to do is be able to tell yourself, what's the total, what do I already know, what's left. So if you look at this is already turned like a rooftop, right? And this 2 here does not represent 2 degrees. It's a name. They're saying angle 2. There's my base angles. So what does the measure of this angle have to be? This angle has to measure what? 50 degrees. I want you to label that, because now what you can set up is angle 2, which is 3x plus 14, would have to equal 50. And there's your equation that you solve. So we would subtract 14 and divide by 3. Yeah, you're just finding the x. So to make your equation, you look to see the expression that they gave you, like where is it in the picture, so right here. And then the goal is, can I find out how many degrees are in that corner? Because if I can, then I just set that equal to it. And that's what makes it easier. So like this problem, right, not on that one, no. We don't need it. Now you could, no, yeah, you don't need it. It didn't ask for me to actually, no, because remember, you already know it measures 50, so you don't need to plug x back in. Number 8, it's turned like a rooftop. I've marked my sides. So let me mark my congruent angles. Base angles are congruent. Do I have enough info to find the degrees in angle 2? Yes, I do. See if you can find it. It's very similar to number 4, by the way. I forgot to take attendance. Okay, so we've done the intro level questions. We've done the slightly more challenging questions because of the polynomial expressions. Now let's look at the grade level appropriate questions, okay? When you first look at them, I'm sure you probably think, I hope she does this one on the board, you know. What makes them more challenging is there's more than one triangle. Okay, so in some cases we'll have things pop up that we've already been practicing, like linear pair, right, adds up to 180. Vertical angles are always what? Vertical angles? Anyone? Vertical angles are always congruent. We also know that the total sum of the angles in a triangle is what? Every time? 180. When you look at number 13, for instance, there's a lot going on here. What type of triangle is on the left? It's isosceles. What type of triangle is on the right? Look again. Do you notice how there's just, yeah, it's also isosceles. There's not a single angle given to us. Everything is in terms of some variable, right? So the approach here is, can you label another angle based on the information you're given? So let's mute. You've got to learn how to mute in your mind certain information and just focus your attention on one thing at a time, okay? So looking at the triangle that I have right here in front of me, I muted out the other one. Is there an angle I can label that's not labeled? Do what? The bottom angle? If I turned it like a rooftop, what would that bottom angle be? 11x plus 10. Do you see it? You'd have to visualize turning it like a rooftop, and then you can mark that, okay, this angle is congruent to this angle, which means this right here is 11x plus 10 degrees. Now, do I have info on all three angles of that triangle? And what do I know the total is? 180. So can I set it up? Yes. You could add all three expressions. Can anyone think of a shortcut when you're going to set up your equation? Is there anything convenient in there? You can add them all. You can. And I encourage that. What do you notice about these two? They're the same. So instead of adding it to itself, I could just multiply it by 2. So let me show you. So one technique is you say, okay, I got the 9x minus 26 plus, I have 2 11x plus 10s. You see it? And they have to add up to equal 180. That's a shorter equation. You will distribute the 2 to everything in the parentheses. Then you'll combine like terms, add them up, and then you'll solve for x. So while the problem looks really difficult, it's actually the same equation we've already been doing. It's just now you have polynomial expressions instead of just an x and just a number. Then I want you to apply the same approach to the triangle that it's attached to right here. These two triangles have nothing in common besides that shared side, and that has no role in the problem. So this is just basically two problems shoved into one right here. I want you to label the missing angle here with what expression it should be, and then I want you to solve for y. If you need help in recognizing what expression it should be, turn it like a rooftop and find your base angles. Did you get x is, or, well, you tell me, what'd you get for x? 6? What expression can I label this missing angle right here as? 9y. When you set it up to get y, what did you find? 7. Very good. Doesn't it feel good to have such a complicated picture actually end up not being that bad? Look at 14. I want to work it because it's a little different. I need you to start recognizing what parts of the triangle you're working with. Okay? There's a common mistake I've noticed among students that start to get parts of a triangle confused. When I say parts of a triangle, I mean we have the length of the sides, or we have the angle measures, right? We have the length of the sides, or we have the angle measures. I need you to understand that length of the sides is linear. Linear meaning I could lay a ruler down and I could measure it, okay? I need you to understand, so this is the sides. Side length is linear. Angle measure, spell it right. Oh, wow. Anyways, angle measure is always in what? Degrees. Meaning like an alligator's mouth opening up, okay? Wrap your mind around this. There's a big difference. This side length, I can lay a ruler down. Angles, I'm talking about opening up and I'm measuring always in degrees. Side length, linear, could be feet, inches, centimeters, meters, millimeters, you name it. Angle measure is always one thing. What is it? Degrees. Okay? Now, I say that because look at number 14. There's a mix of information here. Some of it's linear, meaning the side length. Some of it's angle measures. You cannot mix those two together. Okay? You will never set an equation up with a side length and an angle measure in the same equation. Never, ever. And that's because one's linear and the other one's angle measure, okay? So if you look at it, make a note to yourself, hey, this is a side. There's no degree symbol. It's on the outside, hovering next to that. This over here is also a side. This clearly has a degree symbol, so it's an angle. This has a degree symbol, so it's an angle. So from the get-go, you should know that, okay, this and this expression are the only sides I have, right? They will not get mixed with the other expressions. Okay, so we have several things going on here. Does your mind see an equation you could set up immediately? Which one? Yes, the side lengths. They're both what, Gabe? What do these marks mean on the sides? Equal. So I could set 28x plus 27 equal to 40x minus 9. Right? And solve. These are the sides. I'm going to make a note. Those are sides. Now, once I do that, I found x, which is then going to help me right here with this angle that has x in it. Okay? What'd you get for x? 3. And notice this angle right here has an x in it. What can I do with that 3? What is x? Well, no, I mean, x came from an expression about the sides. But what is the value of x? You just found it. It's 3. This angle right here says 30x plus 13. So what can I do with the 3? Plug it in, right? So 30 times 3 plus 13 is what? 103 degrees. So this angle right here is 103. Now the goal is y. Y is on the outside over here. We do have another isosceles triangle here. So if I mark these base angles congruent down here, could I actually find out how many degrees are in those base angles? Yes. So if there's 103 in the top, how much is left in the total? Take 103 off 180. 77. So how much would each of these angles be? What's 77 cut in half? 38.5. So I'm redrawing the picture here so that you can see, because it's getting crowded up there. What do you notice? What do you notice about this? It's a linear pair. It adds to 180. That's a straight line. That's an angle and an angle puzzle pieced together to form a straight line. So that's 180. So there's your equation to set up. You can either say 38.5 plus this equals 180, or because I know 38.5, I could subtract it off of the 180, and that would leave me with how many degrees are here. So, can you tell me how many degrees would be in this angle out here? How many degrees would be in this angle out here? 141.5? And that's a smaller equation to set up. So 15y minus 1 would have to equal 141.5. All right, I'm going to give you